Hello, everybody. Ms. Wombold here. Thanks for staying engaged and taking an active role in your learning. I'm really proud of you, and you're doing a great job just by being here. Um, this week we're going to be taking a look at standard form of quadratic functions. That's what our notes are called. Just a heads up, this video is going to be a little bit longer, so I really encourage you to take breaks as you need to, or do this in a couple of different parts. There's no reason for you to sit here and do this all at one time if you don't feel up to it. If we get through our standard form notes here, that's going to allow us to do some really interesting things with quadratics later in the week and down the line. So that's why we're starting here today. Just as a quick reminder, um, a couple of features here with quadratics, right? The vertex is going to be an important part. That's our turning point. We can have a parabola that's concave up or concave down. Um, and something that's missing from this is the axis of symmetry. Remember, the axis of symmetry goes straight through the middle of the parabola, and we're going to talk about that a little bit today as well. So just a couple of reminders up here if you need to take a closer look at them. There are actually three forms of quadratic functions, but the first one that we're going to look at is standard form. Standard form is the one that we're a little bit familiar with already. It looks like y equals ax squared plus bx plus c. So we have that x squared term, a, b, and c in order there. So if a is positive, if that first number is positive, then our parabola will open upward. We'll have a concave up parabola, whereas if a is negative, the parabola opens downward. We'll have a concave down parabola. And the other thing that standard form tells us is that value of c. It actually tells us the y-intercept of the parabola, where it crosses the y-axis, and it will tell us a coordinate point 0, c. So let's take a look at this example. It says y equals 2x squared minus 3x plus 9. Let's see what kind of information we can get out of that. So first of all, looking at our a value, right, our a is equal to 2. 2 is a positive number, right? 2 is bigger than 0. So our parabola opens upward. So we have an idea that our parabola will open upward. And then that 9 at the very end, right, our c is equal to 9. So we're going to have our y-intercept at 0, 9. Now, unfortunately, just knowing one point is not enough to make the parabola. Really, if we're going to be making a parabola, we should use at least 5 points. So we're a couple of points short here. And if you're feeling like, well, that turning point would be a really great one to know, right? The vertex would be awesome to know. You're exactly right. That's what we really need to do. For any of these parabolas that we're going to graph, it's super helpful to start with the value of the vertex or the location of the vertex. So that's exactly what we're going to practice doing. So there is actually a formula we're going to use. First, to find the x-coordinate of the vertex, and that formula is x is equal to negative b divided by 2 times a. So those a and b values come from our standard form equation. That negative 1 or that negative b is really like a negative 1 times b. I'm putting a and b in parentheses though, because positives and negatives we know can trip us up a little bit, so it just might be a good habit to have. So this is a formula we're going to be using to find just the x coordinate. But a vertex is a coordinate point. We need a y coordinate. So the y coordinate of the vertex, well, we just plug in our new x value into the equation. Whoops, just a single x value, not x values. And then evaluate, right? We do the multiplication. We used our calculator, add and subtract, order of operations, all that good stuff. So this formula here, I'm going to put it in a little important cloud there. We are going to be using that throughout the week here. It's a pretty important one. So we're going to find the vertex of this parabola, negative x squared plus 6x plus 2. Now, just taking a look, we've got a equals, well, in front of our x squared, we have a negative sign. We know that's a ninja -1. Our b value is 6, and our c value is 2. So just a couple of checkpoints here. We can look at, since a is -1, this is going to open downward, right? And this is going to be the coordinate point 0, 2 for our y-intercept. But really, we need to find the vertex. So our vertex formula, started with the x-coordinate, negative b divided by 2 times a, which in this case will replace b with 6. My lowercase b and my 6's look awfully similar. And then a is -1. -6 and -2. -6 divided by -2 simplifies to a +3. So we have our x-coordinate. And then we need our y-coordinate here. So I'm going to take my original quadratic equation, except for instead of x's, I'm going to replace those x's with 3's. And notice as I'm writing this out, I'm also using parentheses. Anytime we substitute a value back in, we should use parentheses. Now, I can put this whole thing into my calculator, whether I'm using Desmos or whether I'm using a handheld calculator. It will, as long as I've got those parentheses in there, it will handle everything the way I need it to. I can do this in my head too. I get like -9 plus 18 plus 2. Whatever route you want to take, we'll get a y value of 11. So we're going to get a vertex of 3, 11, a coordinate point 3, 11. So again, when we're finding the vertex here from standard form, first step is identify what are our a, b, and c values. And then we find the x value using our formula, and then we find the y value using our original equation. So now we're going to actually kind of put all of this together, all of these pieces together, and look at how do we actually make a graph. If you need to take a break, this is an excellent opportunity to take a break because our next two examples will be kind of, each one is a little bit long. So we're going to graph the parabola y equals 2x squared minus 8x plus 5, starting with the vertex. So our a value is 2, our b value is -8, and our c value is 5. Actually, I don't have to start with the vertex. I'm going to start with my y-intercept, 0, 5. I can record that as my y-intercept, and I can even just plot that point, 0, 5. Now remember, I suggested that you really do need 5 points to graph a parabola. So we'll keep that in mind as we go. Let's go, let's find our vertex here. So again, our formula, x is negative b divided by 2 times a, and substituting our a and our b value. So this will be -8. See why those parentheses are really important? Because it separates our -8 from the negative that was already there, divided by 2 times, and our a value was 2. And so now we evaluate here this -8 is +8. 2 times 2 is 4. So we get an x value of 2. And then we want to substitute that back into our original quadratic. -8. So we have 2 times 2 squared minus 8 times 2 plus 5. And again, depending on how you want to handle this, with your calculator or do this individually in your head with the order of operations, you get a y value of -3. I apologize if you're hearing any sounds in the background. Both all three of my pets here, I've got 2 cats and a dog in the room, and they are um, trying to play with each other while we're doing some algebra. So not super helpful. So I apologize if you're hearing any background noises. So I take those x and y point, and I get a vertex of 2, -3. So I'm going to plot that on my graph, 2, -3. And if you remember from last week talking about our features, if I know the vertex, I also know the axis of symmetry. Remember, the axis of symmetry goes right through the vertex. It's a vertical line right through the middle of the parabola. In this case, it's the line x equals 2. And why that's really helpful is that if I know where my axis of symmetry is, I know where some other points are because the parabola is symmetric. So I know that if I have the point 0, 5 on one side of the parabola, it's 2 spaces away from the axis of symmetry. I get another point 2 spaces away on the other side at 4, 5. So now when I said that we needed 5 total points, we have 3 points now. We got one for free. So if we find one more point, we'll also get it. We'll also get a second point for free, making up our 5 points we need. So since I've got something at x equals 0 and x equals 2, I wonder what's going on at x equals 1. So that's my strategy here. Is I'm going to try when x equals 1, what happens. So I'm going to get y is equal to 2 times 1 squared minus 8 times 1 plus 5. Again, evaluating that however I want to, I will get -1. So I get an additional point, 1, -1, that I can plot. So I get 1, -1, and then its partner on the other side of the axis of symmetry is 3, -1. And so now that I have 5 points, I can draw in my parabola. My graph is done. It's gorgeous. The last thing I should really talk about is my domain and range, but we know a lot about that already. We know that the domain of every parabola is all real numbers, right? Every x value is allowed to be used as an input. Then our range here, we have an imaginary boundary here at y equals -3. So our range is going to be y is greater than or equal to -3. So this is a lot of information that I'm throwing at you, but as you start to practice, you'll start to see how these pieces really all work together. Knowing the y-intercept and knowing the vertex to get our graph started, then using the axis of symmetry to find other points and possibly find other points on our own if that helps us out. Another strategy that I've seen used is making a table of values and putting the vertex right in the middle of the table and then picking other x values based on the vertex. If that's a strategy you'd like to explore, obviously it's an option too. So we're going to do one more example together. Again, if you feel that you need to take a break or rewind or watch something again, please do that. So example 2, we are graphing y equals -2x squared minus 4x plus 7. So I've got an A is equal to -2, B is equal to -4, and C is equal to 7. That A value of -2 means our parabola is going to open down, which doesn't really help me for my graph, but it's a good thing to know in the back of my head. And I've got a y-intercept of 0, 7 that I can plot as well. 0, 7. So next step is to find my vertex. So again, I'm going to use the vertex formula. oops, I keep trying to use v. It's an x coordinate is equal to negative b divided by 2a. So that'll be negative 4. Again, parentheses are our friends. We don't ditch our friends. Okay, so negative 4 is positive 4. 2 times negative 2 is negative 4. And 4 divided by negative 4 is negative 1. Wonderful. Now we just need our y value. So negative 2 times negative 1 squared minus 4 times negative 1 plus 7. Come on, plus 7. And so we can evaluate that, and we will get negative 2 plus 4 plus 7, which is 9. So we get the coordinate point negative 1, 9. Let's just write that up here. Makes a little bit more sense. Negative 1, 9 is my vertex, which means, again, I automatically know my axis of symmetry as well. It goes right through my vertex. It has the equation x equals negative 1. So I can use that to find a third point right across from 0, 7 will be the point negative 2, 7. And then again, I've got 3 of the 5 points that I would really prefer to have. So I'm going to pick another x value. I've got all these x values, negative 2, negative 1, 0. I'm just going to keep going and find what happens when x is 1, and that will give me a freebie on the other side. So let's see, when x is equal to 1, y is equal to negative 2 times 1 squared plus, should be a minus 4. A really common mistake I'll see is accidentally writing down the equation incorrectly. Like, you know what you're doing, but for some reason, like like I just did, you put a plus instead of a minus or reverse. It'll happen. You'll make a mistake. The long story short is that if your graph doesn't look like a parabola, it means you made a mistake, and it means you have something to check. It does not mean that that's the end of the world. It does not mean you'll never get your graph done. It just means you made a mistake, right? And we can always fix mistakes. So 2 units to the right is 1, 1. 2 units to the left is negative 3, 1. And so now that I have 5 total points, oh, look, I confirmed it does open down. That's good, right? That's what my A value was. And then again, I have a domain of all real numbers. And you might start to see this symbol. It's a capital R, but it's got like 2 back legs there. That's the same thing. It means all real numbers. And then our range here is all the y values less than or equal to 9, because the vertex negative 1, 9 is a maximum of our graph. So there are some practice problems for you to check out. Please take your time with these. Maybe just do one at a time and check it. And you can always check using Desmos graphing as well. So for practice problems, you do not have to do them all at once. And it's okay to do one, and if it doesn't go well, you can always join our Zoom meetings and ask questions. I really hope to see you there. So that's it from me here. Check out some of the other resources that I've put on Canvas for you. Again, this is just meant to be a learning opportunity, but for sure, try out this practice. Remember, that's all we can do is just try our best. So you're doing a great job, and I miss you, and I will talk to you later.